Antarctica, a land of icy deserts, howling winds and hidden wonders. For millennia, a thick blanket of ice has encased this continent, holding its secrets captive. But now this frozen giant is stirring. As our planet warms, Antarctica's ice sheet is melting at an alarming rate, revealing a landscape sculpted by ancient forces. What was once a realm of silence is now whispering tales of change, of a delicate balance disrupted. This melting ice is not just reshaping the surface, it is also awakening forces deep within the Earth. Beneath the icy veneer lie slumbering volcanoes, their fiery potential held in check by the immense weight of the ice above. As the ice retreats, the pressure lessens and these hidden giants begin to stir. This phenomenon, a delicate dance between ice and fire, has the potential to reshape Antarctica in ways we are only beginning to understand. The consequences of this interaction extend far beyond the icy continent, reaching across the globe and impacting the very oceans that sustain us. The fate of Antarctica is intertwined with our own. To comprehend the changes unfolding in this remote corner of our planet is to gain a glimpse into the future of our world. Imagine a world encased in ice, miles-thick glaciers pressing down on the Earth's crust. That's Antarctica. For eons, this immense weight has kept a lid on the fiery underworld, suppressing the volatile forces that churn beneath the surface. But remove that weight, even slightly, and the balance shifts. The Earth's crust, though seemingly solid, is surprisingly dynamic. It responds to pressure, bending and flexing under the weight of glaciers. This pressure affects not only the crust, but also the molten rock or magma trapped beneath it. Magma chambers, vast reservoirs of molten rock, exist under immense pressure. The weight of the ice above acts as a restraining force, keeping the magma in check. However, as the ice melts and thins, the pressure on the magma chambers decreases. This allows the molten rock to expand, pushing against the surrounding rock with renewed force. It's like releasing a pressure valve, allowing the pent-up energy to escape. This release of pressure can have dramatic consequences. It can trigger earthquakes as the Earth's crust adjusts to the shifting weight. More ominously, it can lead to volcanic eruptions as the magma, no longer held in check, surges upwards towards the surface. Magma, the lifeblood of volcanoes, is not just molten rock. It's a complex mixture infused with dissolved gases, volatile and eager to escape. These gases, including water vapor, carbon dioxide and sulfur dioxide, play a crucial role in driving volcanic eruptions. Under the immense pressure of the overlying ice, these gases remain dissolved in the magma, but as the pressure decreases, they begin to bubble out of the molten rock like fizz, escaping from a shaken soda bottle. This release of gas further increases the pressure within the magma chamber, adding to the forces pushing the magma upwards. Imagine a pressure cooker, its contents heated and the steam trapped within. The pressure builds until it can no longer be contained and the valve releases the pent-up energy in a burst of steam. Similarly, the release of gas from the magma increases the pressure within the chamber, potentially leading to a violent eruption. Volcanic eruptions beneath the ice can have dramatic consequences. The heat from the eruption can melt vast quantities of ice, creating enormous floods of meltwater that carve channels through the glaciers and flow into the surrounding ocean. These subglacial lakes and rivers can further destabilize the ice sheet, accelerating its flow towards the sea. Section 4, a cycle of fire and ice. The relationship between ice melt and volcanic activity is not a one-way street, it's a dynamic interplay, a feedback loop where one process influences the other, creating a cycle with potentially far-reaching consequences. As ice melts and reduces pressure on the magma chambers, volcanic eruptions become more likely. These eruptions in turn release heat that melts more ice, further reducing the pressure and potentially triggering more eruptions. This self-reinforcing cycle, once initiated, can continue for centuries, accelerating ice loss and amplifying the effects of climate change. Imagine a snowball rolling down a hill, gathering more snow and momentum as it goes. Similarly, the cycle of ice melt and volcanic activity, once set in motion, can gain momentum, leading to significant and potentially irreversible changes in the Antarctic landscape. This feedback loop has the potential to reshape Antarctica, carving new channels through the ice, creating new landforms and altering the flow of glaciers. The consequences of this interplay extend beyond the icy continent, influencing global sea levels and impacting ocean currents that regulate our planet's climate. Section 5. Echoes of a warmer past. To understand the potential consequences of this cycle, we need only look to the past. The Earth's climate has fluctuated throughout its history, with periods of warming and cooling shaping the planet's ice sheets and influencing volcanic activity. During the last ice age, which ended about 11,000 years ago, the Earth's ice sheets were far more extensive than they are today. As the planet warmed and the ice retreated, there was a surge in volcanic activity in many parts of the world. This suggests that the reduced pressure from the melting ice played a role in triggering these eruptions. In Antarctica, evidence of past subglacial eruptions can be seen in the form of volcanic ash layers embedded within the ice. These layers tell a tale of fire and ice, of eruptions that melted vast quantities of ice and shaped the landscape we see today. By studying these past events, scientists can gain insights into how the Antarctic ice sheet might respond to future warming and the potential for increased volcanic activity. Section 6. The rising tide. The consequences of Antarctic ice melt extend far beyond the icy continent. As the ice melts, it flows into the surrounding ocean, contributing to global sea level rise. This rise in sea level threatens coastal communities worldwide, increasing the risk of flooding, erosion, and displacement. While the interplay of ice melt and volcanic activity in Antarctica might seem like a distant concern, its impacts are global in scope. The rising sea levels driven by Antarctic ice loss will be felt by millions of people living in coastal areas, from small island nations to megacities. The feedback loop between ice melt and volcanic activity has the potential to accelerate this process, contributing to a faster and more significant rise in sea levels. This underscores the interconnectedness of our planet's systems and the far-reaching consequences of climate change. Understanding the complex interplay between ice, fire, and sea level is crucial for predicting the future of our planet and adapting to the challenges of a changing climate. Section 7. A glimpse into the future. The melting ice of Antarctica is a stark reminder of our planet's changing climate. As we delve deeper into the icy continent's secrets, we uncover a complex web of interactions between ice, fire, and the Earth's dynamic systems. The potential for increased volcanic activity in Antarctica, driven by ice melt, presents both challenges and opportunities. Challenges in understanding and predicting these eruptions and their impacts on the ice sheet and global sea levels. Opportunities to study these events and gain insights into the Earth's deep time history and the forces that have shaped our planet. The fate of Antarctica is intertwined with our own. By studying this icy continent, we gain a glimpse into the future of our planet, a future shaped by the choices we make today. As we continue to explore the mysteries of Antarctica, we must heed the warnings whispered by the melting ice and the stirring volcanoes. For in their dance of fire and ice lies a message about the delicate balance of our planet and the urgent need to address the challenges of climate change.